So welcome everybody to our 5G day. It's a bit of an extemporaneous affair, but I'm very happy there's been lots of response to it. I should say there are a couple of seats here that are reserved. They're not really reserved. They're just reserved for people to sit in, not for specific people to sit in. So if you don't see something on a chair, don't feel that you can't come to it. First of all, many thanks to Jinfeng Du, whom you just heard, who really helped pull this whole thing together. And also many thanks to all our speakers. And I want to introduce at this point our panelists. Just to call your attention, if you haven't picked up a program, they're back in that chair. And I see most of them have some, but people are moving over to get them. It's near the coffee, so they're strategically placed. We're going to have a panel this morning on 5G. The format of the panel is that I'm going to let each panelist speak for a bit about what he or she thinks are the important issues in 5G. And then we're going to open it to questions from the audience. After that, we're going to have a break of half an hour. I hope there'll be lots of mingling. After that, we'll have talks. There will be a break for lunch. You're on your own for lunch. And then we're going to have talks all afternoon with a break from 3 to 3:30. And this is going to go on until 5:30. So I'm looking forward to an amazing day. I'm really thrilled about all the people who have accepted our invitation. So I'm going to give at this point a very brief introduction of our panelists. So first is Dr. Thierry Klein. Can you hear me better now? Okay, Dr. Thierry Klein. So Thierry is an alumnus of MIT. Actually, we shared the same doctoral advisor, Bob Gallagher. And he has done many things. His career has really been at Alcatel-Lucent Bell Labs, although he has also done some entrepreneurial ventures. And currently, he's the program leader for the Network Energy Research Program at Bell Labs. So in particular, he has been leading Green Touch, which is a global consortium dedicated to improve energy efficiency in networks by a factor of 1,000. He does a variety of both engineering and, let's say, societally oriented engineering work. He serves on the UNFCCC Momentum for Change Advisory Panel. He's the recipient of a Bell Labs President, 2 Bell Labs Teamwork Awards. And in 2010, he was voted Technologist of the Year at the Total Telecom World Vendor Awards. To his left, we have Eric Hardouin, and Dr. Hardouin has been named affectionately by everybody Monsieur 5G. So that's his nickname. But his actual title is that he is in charge of wireless research at Orange, with a very large number of researchers reporting to him. He led the innovations work package of the Celtic project winner. He represented Orange in the physical area standardization group of 3GPP for RAN WG1, which, as you know, is an extremely important component of wireless systems. And as I said, since 2012, he coordinates research on wireless networks in Orange Labs. He has a particular interest in cooperative networking. And he got his PhD from NST-Bretagne. And actually, we overlapped when I was visiting in Bretagne. So to his left is Phil Fleming. Phil Fleming is CTO of North American Nokia Networks. So Dr. Fleming is now CTO of North America NSN. He has broad experience in wireless comms. He's done it all. You can look at his CV and see he's done it all. Thierry asked me to make sure that if people had gone through Bell Labs, I mention it. So indeed, Phil did, sometime after getting his doctorate in mathematics from Michigan. He also was for some time in Motorola. And for 2 years now, he's been head of the Advanced Technologies Group. So to the left of Phil is my good dear friend, Andrea Goldsmith, who also did a stint at Bell Labs. I never did one, so just so you know, it's not... okay. I got a job offer. Awesome. I knew that something good would come out of this. Okay, she's a Stephen Harris professor in the School of Engineering at Stanford. She got her doctorate from Berkeley. She has so many awards, I can't even read them. But among the many things she's done, she was the former president of the Information Theory Society of IEEE, I think the first woman to hold the office, sort of really opening the doors for the rest of us. She's a member of the Stanford's Faculty Senate. She has done quite a bit also of entrepreneurial work, starting 2 wireless companies, one in particular, Quantenna, that you may have heard of. And so we're delighted, of course, to have Andrea. And last but not last is Paul Polakos, who's a Cisco fellow, and in the Service Provider Mobility CTO team. He was for a long time at Bell Labs, where he was director of wireless networking research in Murray Hill and in Paris. His expertise is extremely broad, from MIMO, LTE, femtocells, dynamic network optimization, and he's currently leading a research team at Cisco, in the study of information-centric networking as a foundation for 5G mobile networks. So I think that we have a very distinguished, interesting panel, and I look forward to hearing what they have to say. Thank you. So with that, I think we're just going to go down, and we'll start with the first. Paul, you were now first.
Yeah, okay. There's, I think as we're thinking about, so we just open discussion, I guess, right now. But one of the points that I'd like to make, because it sort of does set the stage for how we think about 5G, is what's going to drive it, why are we even talking about it, why is it relevant now instead of sometime in the future or sometime in the past. And I'm not quite sure, you know, there are lots of opinions on what 5G is and what's driving it. But probably it's growing out of a habit that we've developed, which is that every 10 years we have a new generation. And this is kind of a unique process in the mobile industry. It doesn't occur, say, in the broader internet industry. And it's sort of grown out of, I can give you my opinion on this, it's grown out of the evolution of the way that market needed to be built, starting with 1G and moving on through these different generations. And it's been driven in the past by a very well-defined use case that it was targeting to serve. So the first generation was analog voice, you know, just how do we do mobile voice, that sort of thing. And how do we build a circuit switch network that can support analog voice. And clearly that was a very expensive solution, but it at least proved the utility of being able to do mobile voice. So 2G, we moved into digital voice, better spectral efficiency. 3G, we added some data to that, and broader band carriers that could support a reasonable mix of voice and data concurrently. The smartphone, the iPhone was developed in the mid-2000s, came to market around 2007, 2008, and all of a sudden things changed. We realized the utility of broadband data, that voice was now just an application, and so how do we serve that market, that broadband market? All of it was really targeted towards sort of human interactions, and the device that they used was some kind of a cell phone. So now we're at 5G, and I think if I was going to mark a difference between how we look at in the past, looking back at when we made these transitions and looking forward, 5G is sort of marked by the lack of any single specific driver that we're designing to. It's more the diversity, the expectation of the diversity of devices, the diversity of use cases, and the need for a network that can economically serve these and put us on sort of the right economic foundation to be able to drive investment and to be able to drive a market that doesn't exist today completely. So we have a very efficient network today for delivering the kinds of services that we use today. And the question is, as we look to the future, what the use cases are going to be. And we'll probably hear a lot about that today. But it's mostly predictions that we have and expectations that the market, the direction that the market is going to go in. And those of us that can make the wise predictions about what that market is going to look like will sort of benefit 5G and how we design 5G to serve that well. Ultimately, it comes down to the economic value that we can provide with a new foundation for our mobile networks. So again, maybe just the last point I'd make is really just think in terms of the use cases are really diversity. I mean, we can talk about Internet of Things and machine to machine and everything, but the point is that there's a much greater diversity in our use cases and devices and the requirements of those devices looking forward. And that expectation is something that our feeling is 4G, while it could serve them, probably will only serve a fraction of them on the economic model or the economic framework that we're looking for.
Thanks. So I agree a lot with everything Paul said. It's interesting when you ask the question, what is 5G? And we talked about this at dinner last night, is are you restricting that definition of 5G just to cellular? Is it just when is the next cellular standard going to come out and be adopted, in which case then it does have to be driven by the use cases associated with cellular? Or are you talking more about the next generation of wireless technology? So Wi-Fi is going to go through another generation. Technologies such as millimeter waves, massive MIMO, those are all new generations of technologies. Is that also 5G, even if it's not necessarily incorporated into the cellular systems? And so historically, it's interesting that about every 10 years, there's been a new cellular standard, and usually when people talk about XG, 1G, 2G, 3G, it has to do with cellular. But I would argue that, so by the time 3G came along, so obviously we had to move from analog to digital because analog wasn't efficient in any way. Data, really people didn't know what to do with data. I mean, when I was working in wireless in the second generation systems and they were talking about data, the killer app was texting. I mean, it really wasn't a consensus around how people were going to use data. And when 3G came along, at least what I recall, maybe my esteemed colleagues will remember differently, people weren't buying 3G cellular service. It was not a very successful rollout initially, and then it was really the iPhone that brought the networks to their knees that caused, some consternation about thinking about 4G. The 4G networks, I would argue, were pushed by Flarion because the standard was moving fairly slowly. 3G was working pretty well. And then there was this upstart coming along with a new standard, and so the cellular operators and the vested interests in owning the standard for cellular, I think, developed the 4G standard much faster than it would have happened otherwise. So now, what is the impetus for 5G? Everybody's talking about what's 5G going to look like. And I agree, there isn't necessarily a driving force behind it. And so it's hard to say when that's actually going to come into fruition. What is it supposed to be supporting? When I look at what are the challenges of wireless in general that 5G cellular may help to solve, I see actually a bifurcation of use cases. So there's smartphones can consume about as much data as people can, as possible. I mean, you see this exponential growth in data usage. Most of that is on Wi-Fi now. So people go to Wi-Fi because there's a lot more spectrum there, but Wi-Fi has its own challenges. So can 5G cellular support some of the applications that currently are being driven by wireless? In order to do so, it needs to be much more cost effective than it is today. It needs to have much better performance in terms of supporting high data rates in video than today. So that's one direction that 5G cellular could go in, which is to be more competitive with Wi-Fi. The other direction is for the Internet of Things, and I'll talk about that a little bit in my talk a little bit later, but that's going in a completely different direction. Internet of Things, if you're thinking about watches or thermostats or, cars, these are low data rate, not so much cars, but a lot of these are low data rate, extremely energy starved devices. And the kind of technology that you want to build to support, the next latest and greatest smartphone is very different than the technology you need to support a lot of the Internet of Things applications. So are we going to have one standard, one network for 5G that's going to support both? How are we going to meld together the support of those two different, very different use case drivers? And then another aspect of 5G that I think is really important is integration across different types of networks. So the experience of going from Wi-Fi to cellular right now is extremely poor. Okay, I mean, basically you have to shut down a connection and go to another one. The choice of which network to operate on from a device perspective is also extremely poor. There's much better ways for a device to figure out, should I be talking over a millimeter wave network or a Wi-Fi network or a cell phone network that isn't part of the network structure today. So I hope that in 5G, we see more of a convergence of the different types of wireless networks so that from a user perspective, you don't really care whether the icon on your phone is a Wi-Fi icon or a cellular icon or a Bluetooth icon, as long as you're not paying anymore and you're getting the kind of performance that you want. But today, we don't have the technology or the infrastructure to support really seamlessly going across these different wireless networks. So I don't know if that will be part of 5G. There's technical challenges and other challenges, economics, business, et cetera, in being able to do that. But I would hope that, the 5G that I envision, the Shangri-La of 5G, will incorporate some of that.
Okay, thanks. It's maybe tough to follow up those two. That really covered a lot of ground. What I'd like to say is, first of all, thank you all for showing up here, because I think I'd really like to get your views on what are the deficiencies in the wireless network today. How is it not serving your needs? And I think some of those things will become the driver. And so devices like, for example, Raspberry Pi that is coming out and providing, a very low-cost compute platform that people can innovate with. These are the things that I think will be the drivers for 5G. So right now, what the researchers are really looking at is what more can we do in the wireless space, right? So we can do millimeter wave. We haven't really looked very hard at millimeter wave, centimeter wave. We've used centimeter wave for point-to-point transmissions. What about for user access, multi-user MIMO? Can we do this efficiently? So these are really the research topics that are happening in the physical layer, and then obviously there's aspects like using cloud computing, using virtualization, software-defined networks, and these kinds of concepts, network coding. How do you actually integrate that into the network? So there's things on that side that I think are important research topics. I would like to say something about sort of analogies between 3G and 5G. In my view, 3G was kind of a failure because, in a way, it was a bit of a, kind of a mishmash of things. There was it was voice, but then it had this sort of shared data channel that was really kind of complicated to implement. And in point of fact, what happened was the voice service offered by 3G was very inadequate, which caused the operators to maintain their 2G networks for much longer than they had anticipated. So I think, and the spectrum that came out was too expensive, and the rollout was very slow. I mean, the 3G thing was not a success. You might not have noticed, but anyway, it was not a success. 4G was much smoother because, after all, we did have this driver of smartphones, and in fact, operators who advertised LTE, they marketed it, right? Even though nobody knew what LTE stood for or anything, people bought LTE because they had this smartphone, and there was this promise that it would work better if you got LTE. I hope the same thing doesn't happen with 5G that happened with 3G, which is that it's sort of this mishmash of things, and you put it out there and people don't know kind of what to do with it, and it doesn't really work as well as you want to. So I think it's sort of incumbent on us to do the research and solve the problems and get it out into the field and test it in a way that we didn't test 3G initially, and and again, kind of looking to all of you to help us define 5G and what are the use cases, because there's obviously things that we can't even see today that will drive it. 2-3 years from now, it'll become apparent that that's why we want 5G, but we don't see them now. Thank you.
Thank you. So continuing on the use cases, there has been a lot of effort in the industry to try to identify what are those different use cases and what are the implications in terms of requirements. And as was said before, there is a huge diversity of possible use cases, but there is one in particular which is especially important, is the unknown use case. Because most likely there will be a lot of new use cases that will appear in the future that we have no idea about today. But still the technology bases that we are going to define in the coming years, they will need to be able to accommodate those use cases. And that goes for the concept of forward compatibility. So in short, the technology design should be able to accommodate completely new, even new air interfaces in the future that we have no idea about today. So that's one point. Another very important point from an operator perspective, besides the having more capacity, higher data rates, providing different new services to the customers, is the cost and the energy efficiency. Because energy represents a large part of the operator's OPEX, and cutting down those costs is extremely important to continue to have sustainable networks and operation. So this is part of the larger, I would say, cost efficiency aspect, but it has also, of course, some obvious implications on the environment aspects, which will become more and more critical in the future and are already very critical today. So in our view, and you will see that this afternoon in my talk, the two top requirements for 5G are energy efficiency and cost efficiency. Even higher priority than those central requirements about better performance. And there is another aspect also that I would like to introduce, is the concept of ultra low cost networks. You know that today with 4G, we are trying to simplify the physical layer as much as we can in order to accommodate the machine type communications, where one key requirement is the cost of the device. Because the lower the cost and the higher the number of machines where we'll be able to embed a chipset and make the machine communicate with the rest of the world. But that was not thought from the beginning. So first we designed LTE for mobile broadband, and then we said, okay, now we have a very highly performance technology, but which is also very costly, and this cost is inappropriate for machine type communication because of the cost aspect. So we took the specifications and we said, okay, what can we reduce from now to reduce the cost? And cost aspect is extremely important for machine type communications, but it is also extremely important to provide internet access to the populations which today do not have access to the internet. And in Orange, we have an operator. I don't know if all of you know us. We have operation in Europe, in Middle East, and in Africa. And in many African countries, the countryside or the suburbs are not covered for the simple reason that it is not cost effective to deploy a network there. We would lose money if we would deploy a network because the people there, they don't have money to buy a terminal or to pay a subscription fee to the network. And there is no public funding there to help operators to deploy a network. So what we would like 5G also to integrate is the possibility right from the start to identify what are the critical components that need to be there and what are, I would say, the other ones which will be needed for some services but are not mandatory to have the system up and running. And taking these constraints into account right from the beginning, we will be able to provide options to design very low-cost networks and terminals and be able, hopefully, to provide internet access to those underserved population of today. Thank you.
All right, so I can just take the easy out and say I agree with everything else. Well, first of all, I want to thank you, Muriel, for inviting me. It's always a pleasure to come back. And then before we get to 5G, I just want to get the big elephant out of the room. Yes, Deflategate is overblown, and I still trust in Tom Brady, so let's get that out of the way. So for me, yeah, I still have roots in, I live in New Jersey, but I'm still a Patriots fan, which makes it a little bit hard in New Jersey. But let's get to 5G now. So for me, I'm not sure if it's 5G or 6G or what the number is, but for me, the next era, the next generation of networks, it's really about the network for you. And I think Andrea and maybe Paul talked a little bit about, oh, I don't care what it's a Wi-Fi button or the cellular button and so forth. There's still a lot of things that you as a consumer, as a user of the network has to do to get your network connection. And it should really be about not you trying to find the best network, you trying to figure out how you get your connection, but it should really be the network figuring out where you are, what you're trying to do, what is your device, what is the application you're trying to run, what location are you, maybe even knowing your preferences, your willingness to pay, and then really adjust the network to what you're trying to do. So it's sort of shifting from you adapting to the network really adapting to you. And then the you is really you as a person, and you may have different profiles. It could be you as a professional in your 9 to 5, or you as an individual in your 9 to 5 when you may have different preferences, different willingness to pay and so forth. But it's not just the user, it's also the machines, the objects, the devices. It's really, I think the next era will be connecting everything around us, not just us talking to each other, us talking to machines, but every object around you talking to every object, connecting to you and so forth. So it's really adapting the network to everything that's going on around you, and really putting sort of the services and the applications that you care about at the center of how we control and manage the networks. I don't really know the use case in the future. I don't really know the application services we want to run in the future. So for me, I would say stay with what we know is going to stay constant. And actually, I'm going to steal this a little bit from Jeff Bezos. I heard him speak last week at an event in New Jersey, and he said, I don't know what's going to happen in 10 years, but I know what's not going to change. People always want, in his context, want fast delivery, low cost, and so forth. We don't know the applications, the services, but I'm pretty sure nobody wants to pay more for their cellular service in the future. I'm pretty sure nobody wants to wait a long time to get their data downloads. I'm pretty sure we're all impatient. We want maximum performance, low cost, anywhere we go. So I think if we focus on the constants, then hopefully we'll address all the use cases, the scenarios that people will care about in the future. And in as far as the metric is concerned, I resonate very much with Klein from Orange about the cost per bit. So for me, the metric is cost per bit. You want to get more bits out, but you also want to get the cost down. And the cost per bit is in my opinion, the metric to look at. Where you expand the definition of cost, it's not just your CapEx, it's really your CapEx, your operational expense, your energy cost, as well as your deployment cost of networks. And so really the total cost of deploying, running, managing the networks relative to the value that they provide in terms of the bits and the applications they give you. And I think to do that, you really have this network that has to be continuously optimized based on the circumstances and what's going around it. So I don't know if it's called 5G, but in my opinion, it's sort of the next network is starting an era of automation in networks. And so I would just call it the era of automation in networks. Thanks.
Thank you. Okay, thank you all very much. I think to some extent you're almost getting to the first question I wanted to ask the panel before opening it up to, after a couple questions to the audience, which is, my friends asked me, Muriel, what's 5G? And I start making a bunch of different points as to we want this, we want that. Yes, Muriel, that's nice, but what's 5G? And so I have found it very difficult to explain to reasonable, educated, informed people what 5G is, at least without rambling on. And I was wondering if you had to give somebody who's, again, reasonably educated but maybe not particularly versed in wireless networks, two-sentence definition of 5G, what would it be? I'll start with you.
Well, as I said, I think it's the next network that places you at the center.
Well, for us, it will be the technology that we will operate during the 2020 to 2030 decade.
Yeah, no, I think that is the right answer, Eric. I mean, so you have to go back to 2005 and say, what if you asked that question of 4G in 2005? So would somebody come and tell you some answer that you would then walk away and say, oh, now I know what 4G is? Probably not, because 2005, it was a study item, and 3GPP is what it was, and people were trying to figure out what it was. People were still proposing CDMA air interfaces. People didn't know whether there would be a voice and data separate channel. I mean, people didn't know what 4G was 10 years ago. We don't know what 5G is today.
So my answer depends on which hat I'm wearing. As a entrepreneur, someone who works in the wireless industry, it is exactly what the next cellular standard is going to be. It's there is a study item in 3GPP. It will eventually define a 5G standard, and that will be the standard that cell phones will operate on probably 10 to 20 years from now. Exactly when it comes out, it's hard to say. People expected it to be ready in 2020 because every 10 years we've had a new standard, but I think that's too soon. As an academic, to me, 5G is about what's the next generation of wireless technology, and that can encompass, what's future Wi-Fi going to look like? Where is millimeter wave going to fit into both cellular and other types of wireless? Some of the other more advanced technologies that we're looking at in research is the next wave of wireless technology. So as an academic, I think of 5G much more broadly, and then it's not just going to be what's in a standard.
Yeah, I certainly agree. In the end, 5G is going to be whatever the standard says it is. It's really a question of where we should be driving the standards in order that they actually define it in a way that we think is beneficial. There were a couple of comments that were made that I think sort of underlie some of the motivation towards 5G. One of them, Thierry, you made, which was, how do we reduce costs in some sense? And one can do that within the space of our current application space, or at least our current market space. We have smartphones, we do something with them at a certain cost level. We kind of discussed this last night at dinner, but there are a set of things that we could do with our phones that we don't do because the price points are too high. So within that market space, if we drive what we currently have in the direction of commoditization, really drive costs out of it, we'll start to lower the threshold for some of the applications that we don't do today, and maybe start doing them more. Video on our phones and things like that, which we're sort of blocked from a cost perspective mostly, meaning that the technology is at least capable of delivering video, maybe not efficiently, and that drives the cost too high. So this idea of taking what we have today and commoditizing is one direction we can go in, but then that doesn't really open up the market space to the things that we're not doing today and the uses that and this is, I think, where the IoT stuff really comes in, is that there's this feeling that there's this whole space out there that we don't completely understand, that a new generation is going to grow up expecting that this is what machines do, or these are the support that I have in this technology to help me run my life more efficiently. And that's a very different problem than this commoditization problem. That's actually starting to move into understanding things that we're not doing today that we can be doing. And we'll probably start by doing that with our current commoditized sort of hardware, or in technology, and we'll find, I think there's a feeling that it's not going to serve us perfectly for those very, very new applications. And so I think we're kind of faced with, as we're driving the standards forward, is do we think in the same space and solving problems the way we've done in the past, which really keeps us in this sort of commoditization space, or do we start thinking differently about how we build these systems that are going to support all of this diversity in a more efficient way? I don't know what the answer to that is, and this exercise that we go through, I think, within the standards bodies of looking at use cases is we'll sort of expose a lot. Typically, what's been done in the past is to aggregate all of the requirements for those use cases into a big bucket, and then say, how do we solve this big bucket? And that's where the real problem is going to come, is do we divide that bucket up into separate buckets and then really focus on specialized solutions for these different buckets? Or are we going to do what we've done in the past and say, you know, we should be able to think of a universal solution for everything, and then the motivation generally for that is drive some economy of scale. But there's also a compromise that's done in trying to, from a cost perspective, in trying to do a solution in that manner. So I don't think we really understand those choices yet. Hopefully they'll emerge with the work that's done over the next few years before we really rigidly define what 5G needs to be.
Thank you. At this point, I'd like to open it, and maybe I'll intersperse rather than, because I have a feeling that some people have questions, rather than ask all my questions ahead of time, maybe intersperse them. Are there any questions from the audience? Yes. I'm going to ask you to speak up. Sorry, thank you.
I do have a few questions about the timeline for 5G. One of the speakers mentioned 2020, 2030. But if you actually look at the release 4, like the 4G release, you already have release 11 standardized, release 12 standardized, release 12, release 13 coming up. And today my understanding is that there is no release 11 rollout. Many phones actually are supporting release 10 features with carrier aggregation. And today it's 2015. I'm assuming that by 2020 you'll be done with the release. So you'll still be in 4G. The question is there is no standardization efforts being made in 5G. Nobody even knows what the air interface is. Nobody knows how many antennas are support. Nobody knows what type of access technology is. So what is the future?
Oh, no, just to speak up. Okay, I'm going to repeat your question, particularly so that people can hear it, maybe streaming. So your question is about rollout of 5G timelines, and particularly given the releases that are currently in the works for 4G.
There is a lot more life left.
The demise of 4G is premature. That's right. News of my death are premature, right? That's right. So let people take it. Maybe we'll start in the middle, and then I'm randomizing this. Not really. It's just sort of random. So I don't know. Whoever wants to take it first. How's that?
The operators.
Yeah, send it to the operator.
I will also answer with my hat of having been a 3GPP delegate for quite some time and being well aware of what 3GPP is doing in this with 5G. So there was some discussion. I mean, the very first discussion in 5G in 3GPP happened in the March RAN plenary and SA plenary meeting, where there was some discussion to establish what should be the timeline of 5G in 3GPP. And as you know, one of the things that will drive the design of 5G is also the ITU IMT 2020 process. Similar to the IMT Advanced process that gave birth to the LTE Advanced. So ITUR has released their initial timing for 5G. And in order to comply with this timing, 3GPP will need to provide specifications in, is it December 2019? I have a little doubt here. But I don't remember if it's December or February. Well, anyway. And that set some retro planning for the 3GPP work. And as a matter of fact, it was tentatively agreed that there will be a study item starting in RAN plenary in December this year to launch the work on the requirements of 3GPP towards 5G, and the work in the working groups. So the feasibility studies on the air interface, for instance, will start in March 2016. So these are only tentative agreements. There is nothing carved in the stone for the moment, but this is the main direction that 3GPP is taking. And there is also a lot of, I would say, motivation from some operators, especially in Asia, to have some 5G system up and running by 2020 or even a bit earlier for some of them. And having the specifications closed in 2019 will not allow products for that time frame. So that means that there will be most likely an intermediate 5G release in 3GPP, most likely around September or end of 2018, I mean, with the freeze of the specifications, and that will allow initial products by 2020. But of course, this initial release of 5G will not comply with all the ITU requirements, so it will not cover all the spectrum of requirements from 5G. And what it will do, then no one knows at the moment. But there will be this two-phase, most likely, approach in 3GPP. So one with the specifications frozen end of 2018 for products around 2020, and another one 1 year or 16 months later, targeting rather 2022, 2023 deployments. That will be for the product's availability, and then what the operators will do, it will be up to each operator to decide when they will deploy 5G, and certainly some will deploy earlier than others. Thank you.
Could I just add just a little bit? I just wanted to point out that, you know, in all the previous Gs, except maybe 1G, there was competition. So in 2G there was competition. There, as you know, there were lots of different standards out there, and there were, you know, and 3G there were two standard bodies, 3GPP, 3GPP2. They were competing with each other. So, and those things kind of drive the timelines. For LTE, one thing that hasn't been mentioned here was the rollout of WiMAX and its role in accelerating the standards work. So I'm not seeing that in 5G. So we've got to this world where, you know, we have one standard, the 3GPP standard, which is a good thing, but now there's sort of nothing driving it unless maybe you know, Wi-Fi or IEEE comes up with some other kind of threat, which WiMAX was considered at the time. So that's one thing. And then the second thing to your question is LTE started to roll out in 2010. I mean, Verizon actually started rolling it out in 2010. I don't know if you knew this. Didn't really come into the public consciousness until maybe a couple years later. And even now, I don't think a majority of our revenue in Nokia yet comes from LTE. I think we're still selling a lot of 3G radios. We're even selling 2G radios. So when you talk about, you know, when it quote unquote happens, you have to be a little careful about what that means. So I do see the first 5G type technologies rolling out in 2020 on a small scale.
Okay. So again, I'm more of an academic than an industry person, so I'm opining on something I know very little about, which academics are excellent at doing. So I would be surprised if we see 5G phones in 2020 because I don't see the same drivers as in the past. I think 4G, there were two things that pushed 4G because I think 4G happened before its time. WiMAX was one and Flarion was another. So both of those were a threat. And as a result, I think 4G came out even though there wasn't necessarily a huge need for it. And that's why we're not seeing the kind of monetization of it. 5G, I think there's two potential threats that could cause it to happen sooner than it would otherwise. One is the cable industry is really trying to come up with a wireless strategy, and they're trying to blanket cities with Wi-Fi and trying to basically capitalize on the market that the cellular operators are using. They actually did buy spectrum. Comcast owned a lot of licensed spectrum and sold it back to Verizon, so they have a different wireless strategy. And the other big unknown is Google. So nobody knows exactly what Google is doing, but they do have a wireless strategy. They hired the CEO of Atheros. They're building up a big wireless group. And, you know, they have very different constraints than typical operators because they're not trying to make money off their wireless systems. They're basically building them to enable more revenue from their other businesses like search and data centers and so forth. So that could potentially drive 5G to happen sooner than otherwise. And then finally, the use cases of things like Internet of Things, which can't operate successfully on current cellular systems given the energy consumption and the cost, may end up driving a new standard to support that killer app, which I think is evolving, at least in some segments.
So in the discussion, I think what came out is part of what came out is when is the standard defining 5G is ready? And then the other question is when does the market decide it's time to invest in 5G and there's a real business behind it? And I think you raised a very, very good point, because there's a lot of question around when that transition is going to occur. And that's a really hard question to answer. There are, from this sort of Asian community, there's a lot of focus on we're going to demonstrate 5G in the Olympics in 2018 or 2019, whatever the year is, a couple of events going on. And those are mainly marketing events, really, to show that somebody's ahead, that kind of thing. But in terms of how you build a business that needs to be served by 5G, as opposed to taking 4G, your question about taking 4G further along, it's probably really clear that we're not close to the time when we're going to cap our investment in 4G in favor of moving into a new space. And so one can expect, I believe, sort of over the next 5 years, certainly increased investment in 4G, strictly 4G, to serve not only our current markets, but as much of the IoT market as you can, capture early on those devices that maybe aren't as energy constrained as cars and things like this. A lot of expansion into spaces, maybe verticals, where we can have device and machine type communications on a price, or at least an economic framework that's set out by 4G. I expect that the industry will push 4G as hard as it can, or at least the service providers will try to extract as much out of their investment in 4G before they're going to start to see some tail off in the growth of the markets that they can get into, and then try and lower the threshold for getting into these new applications. And that's kind of the thing, from my perspective, that would be a real economic driver for the deployment of 5G. Now, that doesn't define when 5G gets defined, it just defines when it gets in the market. There are other things that are the unknowns, as Phil mentioned, the smartphone and Verizon deciding to deploy LTE. Let's remember that Verizon wasn't really needing to deploy LTE. Right? They chose to deploy LTE because they needed to get the iPhone advantage away from AT&T. So AT&T, in fact, this was an offensive move against AT&T, forcing AT&T to invest prematurely in LTE, where Verizon had it in their plan all along that they needed to get off of CDMA, they needed to get away from EVDO at some point. If they accelerate that, then they actually accelerate the rate at which AT&T had to make investments.
But if you do recall, Verizon had DO, which was a 1.25 megahertz technology, while AT&T had 3G, which was a 5 megahertz channel. So there was a little bit of that competitive driver as well.
No, exactly. I mean, they were at, we're not as big as, the argument there that
Right.
we're faster, wider band, whatever it is.
Yeah.
It turned out from a performance perspective, the EVDO network and the 3G network were sort of on parity, except for peak rates. But the average rates were typical.
Yeah.
But the truth was, if you could advertise, we have 20 megahertz worth of bandwidth, or 10 megahertz, or about peak rates, or whatever it is, that's a market advantage. And by making the decision to cap their investment in CDMA earlier and move to LTE, they're forcing now their competitor to make investment in LTE also, just to maintain parity in the market. So that was a very clever maneuver. But that's probably what led to the earlier adoption. That competitive drive led to the early adoption of LTE in the United States. If you look in Europe, in fact, it was much slower, and it was much slower because the market wasn't demanding it, and there was still continued investment in 3G. And we'll continue, actually, if you look worldwide at the number of subscribers in 5 years from now, there will still be twice as many subscribers in the world that are 3G subscribers as opposed to 4G. So 4G is not going to really become the dominant air interface, or at least standard worldwide, before the next decade. So when we're talking about 5G now, we're actually talking about 5G coming into a world that's dominated by 3G subscribers. And they are not going to jump from 3G to 5G probably. They will go through the progression of 3G to 4G to 5G, mainly for economic reasons. Again, it's commoditization of 4G. The costs are going to be lower in the beginning. So this whole process, while we sort of focus on the timelines being set by standards, is really going to be driven by the market.
I have a question on that. So why is it that 4G hasn't become more dominant? Is it that it's more expensive?
It's expensive.
Okay.
Well,
Handsets are expensive.
I guess the other, yeah, it is expensive. But yeah, so you got to follow. I don't know.
Let me
Muriel?
just finish then.
Yeah, yeah. I just wanted to add here that voice over LTE is just happening now in the U.S. And in Korea, I believe. Those are sort of the first couple markets that are doing voice over LTE. If voice over LTE becomes successful, and by the way, it's not more efficient, okay, than 2G voice or 3G voice. But if it does, in fact, roll out, that will accelerate the move, I think, to 4G. If it turns out it's not something attractive, either to users or to operators, that will slow down, I think, the move to 4G.
So
4G.
there is a focus. I mean, I don't know what the answer is. I mean, it's certainly logical, but you could argue that all that's going to happen is that there is still significant amount of 3G infrastructure that's in the
Oh
world.
yeah, absolutely.
And if we can't maintain the margins in 3G, we'll just lower them and still make use of that infrastructure. How that gets sort of amortized over the global demand is really hard to predict. But if you just look at past behavior, we still have a lot of 2G in the world.
I think it'd be interesting to hear Eric's take on this one too.
It sort of serves a very, very large community, and it's a pain in the neck for operators to maintain. Well, perhaps, but the point is that how this we just have a complex amount of infrastructure and a market that's driving this, and it's easier to drive down margins in 3G than 4G probably. At some point, you can't go any farther, and 4G will become more cost-effective. But right now, if you can sell 4G at high margins, then it makes it harder to compete until you saturate that high-margin market to start lowering those margins and trying to compete with the older technology. And so I don't know how this is going to play out, but we shouldn't think that just because we have a better technical solution, this is immediately going to drive what happens in the market.
Just to add on that, I agree with what you said. I think that then what's happening with 4G, or people moving to 4G or staying on 3G depends a lot on the countries and on the different markets. In France, for instance, I think most of something like 90% of the phones that we sell today, they are 4G enabled. And the subscription of a 4G, the 4G subscription is at the same price as a 3G subscription. So we are trying to push as much as subscribers as we can to 4G with the ambition to reduce in the future the amount of spectrum that is occupied by 2G and 3G, so that we can reform it to LTE, which is much more spectrally efficient, as you know, that those legacy technologies. But then on the other hand, we have some countries in Africa, for instance, we are just rolling out 4G now in 2015, and there are still some where we don't have 4G yet, also because of the cost aspects. Mm-hmm. So it really depends on the markets. But indeed, when 5G, the 5G technology will become available, there will be a massive number of still 4G and 3G users in the world, and also 2G users in some countries. And when we talk about turning off some technologies, it is not clear that 3G or that 2G will be turned off before 3G. Actually, it is very possible that we will keep 2G longer than 3G. But okay, we don't have any decision on that at this point.
Yeah, I guess the point I was driving at was I agree with you completely. The U.S., Europe are kind of the leading markets. But the infrastructure that we have can get redeployed. Who knows what happens with it? But the point is, if you look sort of at the global community and really where the growth, a lot of the infrastructure growth will be. The question is that infrastructure growth at a global scale going to be in the latest technology, or is it going to be in some retrospective technology? And typically, it's the older technology because that's cheap enough to deploy to bootstrap up people who have never been connected before into being connected. And then eventually they start to need the more sophisticated sort of features and everything that the better technology brings, or the newer technology brings. And again, this comes back to the point that was the purpose of the latest technology just commoditization, or was it really sort of feature expansion and market expansion in terms of market coverage? So it's a really good question, and if you get it right, the answer, you can make a lot of money.
One more thing to add, though, that if you look at Cat 0 and Cat 1, so if you look at the Internet of Things applications, they don't necessarily need 3G, 4G, or 5G. They can use 2G for a lot of what they're doing. And you're starting to see that those older technologies may actually be the solution to some of the new applications. So that makes the picture even more complicated in terms of when you want to turn off some of these older systems.
No, Thierry
Yeah,
wanted to say something.
maybe
now,
just
but-
real quick, because I think a lot of points have been covered. I don't think it's you can define a particular moment in time right now. We're saying that's when 5G that's the birth, right? Is it the first proof of concept in the lab? Is it the first base station that's deployed? Is it the first $1 billion of revenue? It's sort of a continuum, and actually you have people already right now saying they have pre-5G proof of concept, right? So I think it's more, at some point in 10 years we'll look back and say, aha, that was the moment, and maybe it's driven by a particular use case, maybe it's driven by the Olympics, maybe it's driven by somebody trying to completely disrupt the market. But to me it's more like you look back and you're saying that was the moment, but right now it seems to be more continuum, and I said even people, Mobile World Congress a couple months back already said pre-5G, so maybe it's already happened and we don't know it yet.
Very good, yes.
Yes, hi, Greg Whalen. It's been a good discussion, and thank you. You came so close to answering my question. I just wanted to kind of aggregate it. One of the things, I look at technology in business, and it's right in line.
Somebody's trying to give you a mic.
Oh.
Thanks, Jim. There.
I'm going to talk loud. I agree with Dr. Goldsmith. I do think cable Wi-Fi, especially cable voice over Wi-Fi, is a huge threat to the MNOs. And I also think Google is a big threat, especially with their Fi stuff. So I look at it, Dr. Klein started the discussion, or his discussion early, talking about, the user examples. And then someone, I apologize, I can't remember who, talked about, the Wi-Fi versus LTE. And is it or and? And I do see, again, getting back to Google Fi, where at the end of the day, users don't care. They use Wi-Fi because it doesn't hit their data cap, so it's free. And look at innovation, the low end always wins. So let's face it, MNOs looked at Wi-Fi as a toy, right? So the question is, given and I believe the middle guy, talked about the standards, where you have 3GPP and the ITU looking at 5G, and then you have the IEEE talking about Wi-Fi. So you have the technology sort of growing up, looking to solve a business problem, whereas Dr. Klein said, if you looked at the users, mapped it in, so how do you solve the problem of Wi-Fi, LTE, 5G, whatever integration, when you have really disparate standards organizations and drivers?
Thank you. Okay, Wi-Fi and LTE. Plug for my talk.
So you want to answer it first?
No.
I don't really know how you solve it from standards perspective. I just think purely from the technical perspective. Everything is open and available to you as a user, and all these networks are around you. And maybe there's a pricing model, or maybe there's shadow pricing model that ultimately lets you choose automatically what you want to do, so that the networks adapt to you. So I don't really know how this will be settled from a standards or business perspective. I'm just thinking from a technology perspective, you're absolutely right. I don't think you care about it, and the networks should make it so that you don't have to care about it.
Yeah, just maybe to add to Terry's point, it's kind of interesting that we sort of assign a lot of the responsibility for defining this stuff to standards bodies, and we've got to be a little bit careful. I mean, if we look at our current smartphones, Wi-Fi crept into it without the approval of any particular standards body. Just because Apple or Samsung decided, this is a useful thing to put in it. They put their own connection manager in it, which means when you go home, you automatically connect to your Wi-Fi. And the network really doesn't participate in that. This is just sort of a behavioral thing that was a very simple thing to do that serves a very, very important thing. When I go home, I don't even have to do anything special. I know I'm more comfortable using my phone at home somehow mentally, and I'm not thinking about how much am I sort of using, say, my mobile cap. So if we're not careful and we don't recognize what's useful to the end user as a sort of an industrial community, there is somebody in our industry that's going to solve that problem and blindside either the service provider or whoever the dominant entity is that's trying to control things. And so right now, we do have standards bodies that are trying to be very, in some ways, very controlling about what the future is going to be. We're going to define it, everybody will use it. And in the past, there's been a good purpose to that in terms of building universality in air interfaces and economies of scale. But there is a point at which we have to constantly be looking at what is really the benefit of the user, or whoever it is, whether it's a machine or whether it's a person, and how to best serve that rather than how to serve them, but really keep in mind our best interests, meaning us as a service provider or something like that. In the past, we've always talked about a lot of the control being in the network. We don't want to allow the handsets to have control. And I think, we're kind of relaxing some of that thinking, but the real danger is if we don't get it right and we're not thinking about what's useful for the user, somebody will and have a simple solution for it, and that could really hurt the business interest of the larger service provider. I mean, I would ask a question, looking out 10 or 15 years, who are going to be the service providers? I mean, is it going to be the traditional mobile network providers that we have today? Or, are we going to see an Apple in there? Or I'm not suggesting that this is a good business for Apple, but is there just going to be a different player in there that came because the current infrastructure providers, everybody, all of us together, didn't do the right thing, and so somebody else decided to do it and disrupted the industry. So the retrospective, if you look backwards, is 15, 20 years ago. A lot of the players that exist today didn't even exist then. And the names that existed and dominated sort of telecommunications, AT&T, for instance, exists only in the three letters AT&T. It's a completely different company today. They managed to transition, but they're not the same company. So the industry, if we're not careful, we can make at a very large scale the wrong choices, and somebody in the market is going to make the right choice. I just wanted
Did you want to? Yeah.
just one point, and that was mentioned by Andrea before, but I would like to make it clear from our side also, is that for us 5G is not only a 3GPP new air interface. 5G is for us the future internet as a whole, which means new air interfaces, but including from 3GPP and from non-3GPP, like IEEE 11X, for instance, of its future evolutions. It's also a new convergent core network between radio accesses and fixed accesses, and fixed accesses providing then providing the backhaul also for the Wi-Fi access. And having all those technologies managed by a single core network will allow also us to provide this transparent connectivity to the customer, taking into account various criteria, but in particular performance and cost aspects. So depending on what the user wants to do and where he is, what are the networks available with their relative load and quality and so on, then we can direct the user to the most appropriate access network for its own needs.
Right. Just a quick comment. So today, operators have Wi-Fi networks. So they're already, in some sense, integrating Wi-Fi with cellular. But I think the technology needed to do that in a much more seamless, transparent way to the end user, and bring in new technologies as they emerge. That's, we don't know how to solve that problem technically yet, but it's a very interesting technical problem. And I think that's the right solution. I call that software-defined wireless networking, where basically the wireless radios are just a commodity that are out there, and you have this software layer that's managing that commodity, mapping applications and users to the right network, and doing resource allocation over those networks. And that's going to become more challenging, for example, if unlicensed LTE ends up happening. How are you allocating bandwidth between LTE and Wi-Fi? So there's a lot of interesting technical challenges to solve there, but I think the vision of what it should look like is out there. It's just, will it evolve in that way? Because there's not just technical challenges, but there's competition, there's disruptors like Google, and how will that all play out isn't clear. I think this gentleman had his hand up for a while.
Hi, I'm Nick here from the University of New Hampshire. My question is kind of for the panel. Thank you all for coming. My question is kind of more for the service providers. I've been going to conferences and talks over the last few years, and a common panel is always, what is 5G? And I would like to say that I think this is the first time I've heard the most coherent answer to the question as a future network that includes the handling of different types of loads and traffics and different kinds of air interfaces. My question is, on the academic side, there's a huge amount of interest in the Internet of Things and air interfaces for the Internet of Things. And I think you touched on a moment ago about talking about energy efficiency being an important part of it. But I wonder, are a lot of the large service providers, do they even consider that a market that they're interested in? And because it seems to always revolve around a lot of mobile applications and mobile, high bandwidth usages. But what about, I guess, what you see as though, is that a market, and what the challenges are on that side of it?
Thank you.
Thanks.
Yeah, this is clearly a new market. As operators, what we are very keen on getting access to new customers, because as you know, the mobile broadband market in the developed countries is saturated. Everyone has a smartphone. So the best thing to get new revenues is to explore new markets and to sell SIM cards to people or things who don't have one today. And definitely, at least for Orange, Internet of Things is an extremely attractive area. But then the big unknown is how much revenue we will get from that. Because of course, if you have a low-cost device that transmits once in a while, you cannot charge a lot for that. So here, the revenue can only come from having a huge amount of such device, paying just a little amount of money each time. The forecast says billions of such devices in the future worldwide. There is a lot of effort in the industry also to define, even today, the right air interfaces for that. And there are things happening also already using some proprietary technology. You may have heard about Sigfox in France, for instance. So the big philosophy or strategy here is to say that, okay, if we don't provide a standardized technology for that, there will be most likely some proprietary technologies that will capture the market, and then it will be more difficult to impose a standardized technology. And standardized technologies are extremely good also because they allow real economies of scale, so to drive the cost down. So yes, to answer your question, yes, clearly we have a huge interest in Internet of Things, but also a big question mark about how much revenue we'll get from that.
Do you want to talk a bit about the energy aspect?
Yeah, so I think Internet of Things is happening to some extent already today at small scale, right? To get to the 100 billion devices, my thesis is that you really need to solve the energy supply problem. And I think where you have a problem of deploying billions of devices right now is you can't run power lines to them. You can't go around and change AAA batteries on them. So you really need to get the consumption of these things low, and that goes into what is an air interface that sufficiently allows these devices to connect. You need the energy harvesting capabilities and energy storage capabilities up on the devices, and I think Internet of Things will really happen at the very large scale with then the revenues that come from billions of very small pieces of revenue once you solve this deployment problem, that you can really just deploy them very simply everywhere. And I think from my perspective, from an energy perspective, it's really the consumption, the harvesting, and the storage have to really match, and there's sort of a gap right now. And that's why I see the interesting challenges from a research perspective in Internet of Things.
So just a quick comment on that, which is when you think about new air interfaces, one thing you can do for extreme energy efficiency is send power wirelessly. And that can actually be part of the communication standard. So you're not just sending information, you're sending power as well. So that may end up being part of whatever 5G to support IoT ends up being. But you don't hear too much discussion about that now. So I think that's an interesting avenue of potential enabling of these energy constrained devices.
Thank you. So I was curious about if we look back at, say, 2G, 3G, and 4G, and look at sort of how this has affected the business model and the business of the operators. It seems like something where, in the beginning, standards bodies get together, the technology's almost there. Initially, a lot of money has to get put in to build the infrastructure, so it's a huge investment. Then there's a lot of testing going on. The initial customers come, and it sort of goes through a cycle. Competition comes, and then some of the products get commoditized, and then it looks like it goes on to a new technology. So I was curious if you look back at 2G, 3G, and 4G. How that process has gone, and then as you look at 5G and all the new opportunities and all the new services and everything else that could be offered, does 5G look like it may be similar to what we've seen before, or might the economic model and kind of how the business evolves look very different?
Well, as we said several times already, 5G will be unique in the sense that it will cover more than one use cases. And as you said, there will be a lot of new opportunities. And the motivation to deploy 5G will be about, I think, two main drivers. First of all, the capability of the current networks to accommodate the traffic in a cost-efficient way. And the second one to exploit those new services that will be made possible by 5G. Then in terms of the investments, there is one big change which is also coming. It's this software-defined networking and network virtualization. In the past, we used to deploy dedicated hardware for the base stations, for the core network, and so on. And in the future, we will be able to update the core network elements, the radio base stations, just by software upgrades. So, of course, we will still need to renew the hardware because to get more and more processing capabilities and so on, but maybe less often than we used to. And another thing also that is important to consider, when we talk about a new generation, often people think, okay, there will be a need for huge additional investments to deploy the new technology. But actually, even with the current technologies, operators regularly renew their hardware. And it happens like every, 7, 8 years. So even if there was no 5G, at some point we will renew the hardware. And at this point in time, it's always what operators try to do is to acquire some hardware which is ready for the next technology. So this new investment aspect is maybe not that important when we talk about deploying a new technology. What is absolutely required when you deploy new technology is new antennas if you want to address new spectrum bands. That you cannot do without that. But for the baseband aspect, then we need to renew the hardware anyway.
I want to be the first one to say Moore's Law here. So every 10 years, as you know, the hardware just gets massively more capable. And that allows new algorithms, it allows new technologies. And I think as Eric said, it's only sort of natural that you would take advantage of that in your network. And so I think in addition, if you remember, the market has grown so much, sort of year on year. You look at every 10 years how big the market gets in wireless networks. And so it's really been justifying, this rollover to kind of new hardware as well. So, and I don't see that pattern stopping anytime soon. I think we're in for another 10 years of Moore's Law, as far as I know. And the usage is continuing to grow. So,
So I have two comments. One related to Moore's Law, because it's not universally agreed that we're going to continue on that path. And it's also the case that,
I'm just listening to Intel.
This is
Yeah.
why we have a moderator.
Yeah, no, so there's two things. I mean, the view at Stanford anyway is that maybe we're coming to the end of it. If you look at 28 nanometers as, perhaps the cost and the efficiency and all that, we don't necessarily see the curve of Moore's Law continuing. When I talk to my
In that technology.
colleague, yeah, maybe there'll be a new breakthrough technology. So that's one thing. But another thing is that a lot of what we've seen in terms of the increased capabilities of hardware is parallel processing, which is energy hungry. So the question is that, yeah, maybe your processing is doubling every year and a half, but what's the energy cost of doing that? So that was one point I wanted to make to follow up. But a larger point related to where's the innovation going to come from, and how 1G and 2G and 3G has evolved. Are we going to see something similar to 5G? One of the things that I see in Silicon Valley is there isn't a lot of appetite to invest in carrier-related technologies. If you go pitch a company that's going to, sell into the operators, cellular systems, you will not get much of a warm reception. It's very expensive these days to do a chip company. So if you want to innovate at the chip level, VCs aren't funding chip companies, and you can't get those funded through angels or other ways of doing investments. My chip company, Quantenna, raised almost $200 million, and they're still private. Okay, that's a huge investment by VCs. So where's the innovation going to come from in terms of the hardware and the algorithms? The operators don't build those things. They buy them. Many of the big companies like Qualcomm and Broadcom Broadcom got out of the LTE business, right? So I think it's an interesting inflection point in the industry in terms of startups are not really developing these technologies because they don't have the funding to do it. The big companies, Qualcomm, I would say, is also at an inflection point in its own lifetime of where its next, wave of revenue is going to come from. Broadcom's out of the LTE business. Who's going to be developing all these algorithms and technologies and chips? I think is unclear, and so talking about where's the innovation for 5G going to come from, I think is an interesting question that's not clear.
Yeah, I guess
Just
for
volunteer
the
to do it.
for the purpose of this crowd here, there is innovation going on in Ericsson and Nokia, and Huawei and other large companies that are providing the infrastructure. There's a tremendous amount of innovation. There's a lot of opportunities for innovation for engineers in those positions. There's also innovation going on in the operators research groups. One of the reasons you don't see startups being able to crack into this is because the large operators don't want to buy equipment from a small company. So, but what happens with, I know in Nokia, is if they're very interested in a small company, they will come to us and they will say, will you buy that small company and integrate that technology, into your business line? And but sort of more often than not, things that are happening within Nokia are, what should I say, maybe good enough, so that maybe that acquisition doesn't make sense. So, I mean, that kind of stuff is happening all the time behind the scenes, and maybe people don't see it. As well, I think although the pace of standards is a bit slow for most people, there's still a lot of innovation going on in standards, and there's a lot of patents being generated out of the standards process. So, and there's a lot of, those people that go to standards are really very good people, and they're very up on the current technology, and they pull like publications that come out of academics, work that's going on in small, in startups and so on. That's pulled into the standard, and it really does influence the standard. You may not sort of be aware of it if you don't attend the meetings regularly.
So I think most of the questions so far was kind of abstract, like about the broad field, and it might be really reasonable because the whole thing is kind of a little bit vague. So, but I want to ask a little bit more details about. So far, I think most of the people in academia or like industry are thinking about. I mean, they're mostly thinking about the lower layers, like the Phi and Mac layer. But if we really are caring about having a real network, we should also at some point think about the higher layers. But I really want to know what's the reason that there almost nobody working on that part. Is it like less important, or I don't know? I just want to know your opinions. Thank you.
I think Muriel's a Phi person, so that's why we're talking about the Phi.
My talk is going to be entirely at the higher layers. Back to you, Phil.
You're right. Certainly, we've been, at Cisco, we've been focusing more on the upper layers, realizing that in the past, generally the standards have been dominated or at least driven by fire layer concerns, or at least access layer concerns. And then what's the supporting network that needs to be behind that to support that access? So, in this process of maturation of our industry, the mobile industry, I talk about it that way, there have been very, very specific drivers, as we talked about before, from the use cases that have been driven sort of, we need a new air interface. We've gotten to the point now where we're starting to look more carefully at that air interface and say, is this good enough? If you look at the spectral efficiency that we get, it's relatively good compared to what's theoretically possible. It's remarkably good for a commercial system, something that's not military or something like that. But there's another sort of point, I think, that in what you made, which is that when you build this system, there is this entire structure of layers talking to layers. And the approach that we've traditionally had in the mobile industry is to build a vertical solution. We're going to build a core network that really talks to a specific air interface. And we're going to try and define that air interface to serve all of the use cases that we needed in the past. But that there was a tight coupling between that air interface and the rest of the network that was required to support mobility and all of the other services that you'd put on in authentication and whatnot. And that's sort of complicated. It's protected the industry because it said if you want to be mobile, this is the way you build a device. It also sort of created this problem with respect to, say, something like Wi-Fi, which was a very useful thing, but somehow couldn't participate in at least the upper layers in a simple way. And so there was a lot of standards activity. How do we integrate Wi-Fi into the mobile network? And you'd think, why does that really require a whole standards effort? Why can't you just plug Wi-Fi directly into a network that would support it? I can do that with IP and Ethernet. And so there's something very complicated about the way that we've approached the design of our up to 4G networks that's made it difficult for any new innovation to occur at the access layer and become a part of our network, if it was a useful thing, without a major generational change. And as we look to 5G, we may think that this is the time when we now have to break that connection and make that a simpler, or at least a more loosely coupled connection. So that in fact, after we define our 5G network, not just the access, but the entire network, we can allow more innovation to occur in the access layer to serve the kinds of use cases that we've been talking about in IoT without modifying or requiring a new generational change or modifying our core network. That we can introduce, that anybody can introduce something new into this network and follow a richer sort of evolution path and build a richer ecosystem than we have today, which really has a few dominant players in it.
I would just add a little bit to it. Maybe we've not done it justice here on the panel, and that, or maybe it's not visible, but I think there's actually a lot of work going on above the 5 MAC layers. So it may not be quite visible, or we have not talked as much about it, but I think there's definitely work going on, and I think Phil mentioned SDN, NFV. I think there's a lot going on that. We know Muriel from the whole content distribution. So I think there's a lot of work going on, and I think ultimately, if I go back to the first point I made about putting you at the center of the network, you have to really look at the end-to-end network, because let's face it, the network is just responsive. The primary function of the network is to move content around and find the best way of moving the content, processing, storing, distributing the content, right? So I think, and certainly from an energy perspective, you have to look at the end-to-end picture. So when you focus on the energy aspects, you definitely put the entire network.
First here and then Nancy. Sorry, this gentleman had his. Sorry, and then Nancy, you'll be the closing question, Nancy.
Hi, thank you. Great talk. I'm from Analog Devices, and I have a question sort of at the lowest level of things. So in the past, we've developed infrastructure, sort of the chips, and going forward, every generation, they're all power consuming, where they require higher power, right, in terms of 2G, 3G, 4G, and that's been the progression. And now 5G, you're seeing IoT devices, they have to have no power almost, right? And then, so for somebody like us who are developing chips, it's completely different. So why would you want to put something, an IoT, on a 28 nanometer or much lower process node, which is much more expensive and much more no power? I mean, you could put it in a very high geometry process. So they're sort of completely different. Is this the right way to actually roll the IoT applications into this 5G and then sort of say, oh, you have to deal with it now, and then we'll do these things in software? Just a question.
Excellent question, yeah.
So I'll just make a quick comment. I think some of the way I describe IoT is back to the future in the sense that, the fact that 2G standards may better suit IoT than 4G standards, that older technologies in terms of silicon, which are maybe more energy efficient and certainly a lot cheaper, now they're bigger, but that's probably okay, may be the best suited thing. So I think what I like about IoT, both from a commercial perspective and from a research perspective, is that it really requires a completely new way of thinking about how are we going to support these very low cost, very energy efficient devices. And I think that that requires innovation from a research perspective as well as from a business and commercial perspective. So yes, it could very well be that, we go back to 130, or something like that. That's the best solution.
Yeah, I was also going to, again, bring up this Raspberry Pi, which I think is an interesting case, because they've managed to put $35, very small computers in the hands of many, many hobbyists. I don't know if you know, but they've sold 5 million of these in the last 2 years. And I think there's room for other opportunities. So, I was talking to the CEO, the other day and asked him, when are you going to put a radio on this thing, So I see that as being a very important platform for innovation, as hobbyists and, startups. And I don't know if you've gone on the websites and seen all the applications of Raspberry Pi, but it's pretty amazing. You have one, yeah, sure. I'm sure all of you have. I'm probably the only one that doesn't have one.
I don't have one. I never
Anyway, yeah. Anyway, I do see that sort of grassroots effort, coming up, and all of a sudden you're going to see all these different IoT devices coming, basically from hobbyists.
Nancy, you're the last question.
Yeah, so there's a lot of building and design work going on, but I'm thinking from the point of view of a distributed algorithms person. What do you see as the main algorithmic challenges? And this can be at the low level of communication protocols, but I'm also thinking at the higher levels where you could define an interface to be basically a programming model, an abstract model, and then design algorithms to do things like maintain virtual structure over a network or maintain data in some way.
Yeah, I would love to answer that. So I really think that the machine learning algorithm area is untapped in communication networks. So there's kind of this huge body of mathematics that have been built up over the last 10 years to deal with very large dimensional data and data that's coming in very quickly and so on, and to actually learn from it, in a maybe an unstructured way. So I feel that this is an untapped thing that we haven't talked about yet, and those algorithms and the mathematics behind those algorithms, I think, will have a pervasive influence in the algorithms of 5G.
Okay, so those are basically centralized monitoring algorithms. If you collect a lot of data about the network and then make decisions, but you could also imagine distributed versions of this where individual nodes make local decisions.
But there's also distributed versions of the machine learning that are kind of multi-layer. Those kinds of ideas. Like, for example, how would you map a multi-layer neural network onto a communication network, for example?
So I see two dimensions where distributed algorithms are important. One is just going back to this notion of software-defined wireless networks, where you've got all these radios that are just commodities, and you're trying to optimize the resource allocation of bandwidth and power to those radios. Now, you can do that in a centralized way, but even you go back to 2G and trying to do optimal frequency allocation in a very simple protocol was an NP-hard problem. So you want distributed algorithms to do that, and now you've got a much more complicated resource allocation problem. Now you try to map those resources to the applications from energy perspective, from cost perspective, all of that becomes a very complicated algorithm. If you do it fully distributed, you might end up in local minima, and we've seen that even in simpler scenarios. So, but if you do it fully centralized, then there's latency and cost of going up to the cloud to do the computation. So I think this continuum between fully distributed and fully centralized is something that I haven't seen explored very much. So that's an interesting, very interesting dimension and a hard problem. Neighborhoods of, yeah. And I think that the other dimension is the monetization of the Internet of Things is big data processing. It's not just that, okay, I've got my watch that can do something. It's really being able to collect a lot of data from these devices and do something with that data that has value. So there's a whole data processing element to that. Again, it doesn't necessarily need to be fully centralized. Is there a distributed version that allows, the application to provide value to these devices? And so I think the killer apps for that are still unclear, but there's got to be a distributed algorithms piece of it, because if everything is centralized, then again, latency, cost of going up to the cloud, and so forth. So I see those are kind of the two domains where distributed algorithms are, could play a big role, but the technology isn't there yet. The problems aren't even well formulated, let alone solved.
It can be cheaper to study this, sort of play around with it, try different algorithms with different interfaces, get some good ideas, rather than try to deploy something.
Yeah, I agree certainly with Andrea's last point. I was waiting for somebody to say big data, and finally we heard big data. So, but I think especially, Andrea said big data. So we got Moore's law, big data. Has anybody said 6G yet? So I think especially we talked a lot about IoT. When you get to IoT, I think it's the real-time part and the scalability, how you handle the information that comes from 100 billion devices. Some information may be very locally interesting, some may be very globally interesting. So I think it's really the information that comes from it. How do you sort through just the knowledge that's in the bits? And this afternoon I have just sort of on my last slide say, how do we go from bits to information to knowledge? because I don't care about 100 million sensors, but I care about the one that says something's happening here. So how do you sort through that? And maybe we talk big data, but maybe it's small data. I'm looking for that one piece of information that's in that ocean of stuff.
Interesting data.
Yeah, interesting data. Data that I can act on.
One short comment on the fact that there are, one of the biggest questions at the moment for the 5G architecture is where we will put the different functions. And indeed, looking at from the perspective of everything being software defined and virtualized, there will be some of the functions that will have value from being close to the radio node for latency reasons, for instance. Others, like when you want to aggregate some, information from different sensors, for instance, over a country, then you will need to have all of them gathered to a central node. And then you will have also some aspect about processing capabilities. Most likely, the largest processing power will be in huge data centers that you will not have very, in a lot of places. And all those questions about, okay, where to put each particular function is the topic of a lot of questions today. And that will need to be solved, of course, to design the real system.
Thank you. So with that, we're 5 minutes over. I'm going to just ask you all to join me in thanking our wonderful panel. Thank you.